This video is going to look at three new trig functions: cosec, sec and cot. However, they're not entirely new because they're derived from the three that we know about already: sine, cos and tan. So, let's have a look. The first one that we want to have a look at is cosec, and that is defined to be 1 over sine. So 1 over sine theta is equal to, now to give it its full name, it is the cosecant of theta. But we shorten that to cosec theta. The second one follows the same line, 1 over cos theta. And its full name is the secant of theta. But again, we shorten that to sec theta. And the final one, 1 over tan theta, equals, and its full name is the cotangent of theta. And again, we shorten that to cot theta. Now, why do we need these? Well, first of all, they will help us to solve trig equations. Secondly, they're involved in identities. And third, they come up when we do calculus, particularly when we do integration. Let's just have a look at one example of where they might occur in terms of basic identities. So the basic trig identity that we've got is sine squared theta plus cos squared theta equals 1. And if I choose to divide everything on both sides of this identity by cos squared, then I'll have sine squared theta over cos squared theta plus cos squared theta over cos squared theta equals 1 over cos squared theta. And so this one is sine over cos all squared, so that gives us tan squared theta, plus cos squared into cos squared is 1, equals, and then 1 over cos squared is 1 over cos all squared, so that is sec squared theta. So there's one of our new trig functions popping up in an identity this time. And there is a similar one that we can get if we divide throughout by sine squared. And if we do that, we end up with 1 plus cot squared theta is equal to cosec squared theta. So they're the other two trig functions that we've just introduced, again pop up. Let's have a look at what might happen when we reach the later stages of solving a trig equation. So let's take cot squared theta equals 3 for theta between 360 and 0 degrees. Well, we begin to solve this by taking the square root. So cot theta equals root 3 or minus root 3. Remember, we take a square root, it has to be plus or minus. Now we might think, well, let's just look this up in some tables, or let's take our calculator. But do we really need to? We know what cot theta is. It's 1 over tan theta. And that's root 3 or minus root 3. And now we can turn this one upside down to give us tan theta equals, and we can think of each of these as being root 3 over 1 or minus root 3 over 1. And so we can turn these upside down to get 1 over root 3 or minus 1 over root 3. And now it's in terms of tan theta. And this is now one of those special values of our trig functions. In fact, 1 over root 3 is the tangent of 30 degrees. So we know that this has one solution that is 30 degrees. But what about the other solutions? Well, let's have a look at those. Sketch of the graph. tan theta, 0 up to 90, from 90 up through 180, up towards 270, and then stopping there at 360. So that's 0, 90, 180, 270, and 360. And the tangent of 30 is 1 over root 3. So somewhere here is 1 over root 3 coming down to 30. So, of course, the next one is across there. And the symmetry tells us if this is 30 on from 0, this is 30 on from 180. So the next one is 210 degrees. Minus 1 over root 3, well, that's going to be somewhere along here. And again, the symmetry tells us if this is 30 on this way, then this one is 30 back this way. So that gives us 150 degrees. And we've got another value here, which is going to be 30 back from there, which is going to be 330 degrees. So solving equations that involve things like cot and sec and cosec is no different to solving equations to do with sine, cos and tan, because we just turn them into sine, cos and tan. To conclude this, we're just going to have a look at the graphs of these three new trig functions. And in order to do that, we'll begin each one by looking at the graph of the related trig function. So to look at cosec, we're going to look at sine first. So what does the graph of sine look like? We'll take one complete cycle between 0 and 360. So with 0, 180, 360. And the peak and the trough are in between at 90 and 70. And that goes from 1 down to minus 1. And what we're going to graph now is cosec theta, which of course is 1 over sine theta. So let's set up similar axes. So I'll mark them off. There's 90, 180, 270, 360. Now, here at 90, the value of sine is 1. So at 90, the value of cosec must also be 1. So I'm going to mark it there 1. Here at 270, the value of sine is minus 1. And so at 270, the value of cosec must be 1 over minus 1, which again is just minus 1. So there are 2 points. What about this point? Here at 0, the sine of 0 is 0. So the value of cosec would be 1 over 0. But we're not allowed to divide by 0. But we can divide by something a little bit away. And what we can see is that would be a very, very tiny positive number that we were dividing by. So if we divide 1 by a very tiny positive number, the answer has to be very big, but still positive. So we have a bit of curve there. Let's have a look at 180. Well, at 180, sine of theta is again 0. So cosec is 1 over 0 at this 180 degrees. Let's go a little bit this side here of 180. And the value of sine is really very small. It's very close to 0. So again, 1 divided by something very small and positive is again something very large and positive. So let me put in an asymptote, and we've got a piece of curve there. Now, this curve goes like that, and what we're seeing is that this curve is going to come down and up like that. And it's going to do the same here, except because what we're dividing by are negative numbers, it's going to be like that. So there's our graph of cosec derived from the graph of sine. Let's take now cos theta. We'll do the same. We'll take the graph of cos theta between 0 and 360. And the extreme values will be -1 and +1, 90, 180, 270, 360. Just make that clearer. And so let's have a look here. Mark off the same points. And we're graphing sec this time, sec theta, which is 1 over cos theta. So again, let's mark some points. Here, when theta is 0, cos theta is 1. So sec theta is 1 over 1, which is 1. So we'll mark the 1 there. Here at 180, cos theta is -1. So sec theta is 1 divided by -1, and so we'll mark -1 here. Here at 90, we've got exactly the same problems we had before. The value of cos theta at 90 is 0, so 1 divided by 0 is a very big number. Well, in fact, we're not allowed to do it, so we have to go a little bit away from 90 to get a value of cos theta, which is very small, close to 0, but positive. And if we divide 1 by that small positive number, the answer that we get is very big and positive. So we have a bit of curve going up like that. What about this side of 90? Well, this side of 90 we're dividing by something which the value of cos theta is very small, but definitely negative. So the answer is going to be very big in size when we divide it into 1, but negative. So a bit of the curve here coming down to there. Same problem again at 270. So we can see that the curve is going to go round and back like that. And then here again at 360, we're going to be able to mark that point. We're going to have that one coming down like that. So there we've managed to get the graph of sec out of the graph of cos. Let's now have a look at the graph of tan theta. Mark these off, 90, 180, 270 and 360. And now we'll have a look at cot theta, which is 1 over tan theta. So we'll take the same graph, and I'll do the same as I've done before, mark these off. So we're using the same scale. Okay, let's have a look what's happening here. This bit of curve between 0 and 90. We begin with something for tan that is very small but positive, just above 0. And then it gets bigger and bigger and bigger as it rises. The value of tan theta rises towards infinity. Well, down here, the value of theta is very near to 0, and so tan theta is very small but positive. So when we divide into 1, we're going to get something very big and positive. So a bit of curve there. Up here, the value of tan theta is enormous. It's huge. So if we divide something huge into 1, the answer is going to be very nearly 0. And the closer we get to 90, the closer it will be to 0. So now, if we look here, we can see we've got something very, very big, but negative. So the answer is going to be very, very small, but also negative. So it's going to be coming out of that point there. Here at 180, got a problem. At 180, tan theta is 0. 1 over tan theta is therefore something very, very big. So we can put in an asymptote, and we can see we've got exactly the same problem here at 360. So if I join up what I've got and the direction of what's happening, we're getting a very similar curve, and repeat it over here, because the curves are repeated. We're getting a very similar curve, except the other way around. So, we've seen again how we can derive the graph of cot theta directly from the graph of tan. So remember, these three new functions, cosec, sec, and cot, respectively, they are 1 over sine, 1 over cosine, and 1 over tangent. We can use them to solve equations, but each time we can get back to using sine, cos, and tan to help us work out the angles.